So please take a seat. Okay. So good afternoon, Professor Lam, Professor Chen, Professor Hui, and students. Okay. Welcome to HKBU and welcome to our first capacity building seminar on the topic of climate change 101. And I'm Yan. I'm a lecturer at HKBU. First of all, I wish you all a happy Lunar New Year. So today's event or today's seminar is a very special collaboration with the University Climate Ambassador Program, which has brought students from different universities together. First of all, we have students who enroll in Global Challenges course at HKBU. We also have students from the University of Hong Kong, at the Education University of Hong Kong, and Leung University. So some students may curious about what is UNICAP, University Climate Ambassador Program. So I would like to invite Professor Chan, Janet Chan, the Chief Program Leader of the UNICAP, as well as the Associate Professor of Teaching at Hong Kong U to share the program and its initiative with us. So Professor Chan, please.
So thank you very much. Thank you, Dr. Guan. And 恭喜發財! 恭喜發財! Happy New Year. So today I'm very glad on behalf of the University Climate Ambassador Program, UNICAP, to introduce a bit to you guys what is it about. So as what Dr. Guan mentioned, UNICAP is a interinstitutional program which engage Hong Kong U, HKBU, EDU, and Leung University. So it also involves external parties like the environmental professional bodies like the HKIQEP, the EMHK, the Environmental Management Association of Hong Kong, as well as the master program in environmental management from the University of Hong Kong. And we are also having some NGOs as well, like WWF and also some other like the ESG podcast program, so as to provide a more diverse learning environment for the students that is joining the program. So we hope through this program to bring students to have some more sustainable education for sustainable development experience, so that students can really be engaged as part of the climate action. We adopted the students as partners approach so as to empower students to carry out their climate action. So these are the team. So today we have Professor Tommy He here, and then we have Dr. Yan here as well. So be part of our program team. All right. So we have the project coordinators here. So I think you have seen them as well when you just entered the room. So as I mentioned, we have various partners in this program so as to enrich students' learning experience. So we have mentors who are the main project drivers of this program too, apart from the students. So we have 22 professionals in the industry as well as from the master program so as to provide more engaging experience, fruitful experience to the undergraduate students like you guys. So this program, we have 6 phases. So including the team building. So we have already finished the team building events. And then here today, we move to our first capacity training section. And then we will have the mentorship and then co-creation section and climate action execution. And then finally, we have the project showcase. So today, as I just mentioned, this is our very first capacity training seminar. And then we are very honored to have Professor Leung today to give us a talk about the climate science 101. And then afterwards, we are having some more activities that we welcome you all to join. So that's what I want to share. So may I now pass the stage to Dr. Yang? Thank you.
Thank you, Professor Chan. So I'm also pleased to introduce our guest speaker of today's seminar, Professor Leung Mo. Professor Leung is an adjunct professor at the University of Hong Kong and the former assistant director of the Hong Kong Observatory. And he was also appointed to various bodies, advisory bodies of the government, including the Council for Sustainable Development. So with his extensive experience and the expertise in climate change and sustainability. He's going to provide us with a lot of insights on climate change, on this pressing issue, as well as what are the impact behind on our planet. So before we listen to Professor Leung's presentation, may I now invite Professor Leung, Professor Chan, and Professor Hui to join us for a group photo with the online participants. So for online participant, would you please turn on your camera and get ready. And our project coordinator, Jason, will facilitate the process.
Okay, so everyone in the Zoom, please open your camera, turn on your camera, because we're going to take a group photo with the guests together. So, okay, so are you ready? So, 3, 2, 1, cheers. Okay, one more. 3, 2, 1, cheers for the Zoom students. Okay, thank you so much for everyone in the Zoom.
So Professor Chan and Professor Hui, please be seated. And I now pass the time to Professor Leung for your presentation. Thank you.
Thank you. Hello, good afternoon, and happy birthday to all of you. Do you know that? Do you know? Well, according to the Chinese tradition, this is the 7th day of the Chinese New Year, and it is birthday to all. So we call it Yan Yat, the day of for human being. Thank you, Professor Chen and Dr. Guan for having me this afternoon. Normally, a course for climate change runs 13 lectures, 3 hours lectures, and this is going to be very condensed. I know that you come from various backgrounds. Some of you may know quite a lot about climate change, but some of you might not. So for those of you who already know quite a lot about climate change, ask you to bear with me for some of those basic concepts. All right, so that is the kind of scoop that I'm going to share with you today, overview of climate change, differentiation between weather and climate, carbon cycle, because we're talking about carbon dioxide, so carbon is a very important element, impacts of climate change. And lastly, I think most importantly, should we be pessimistic or optimistic about climate change, right? If everyone feels pessimistic, then it seems that there is no point doing anything at all because we are doomed. We are doomed. So why don't we spend the rest of our life enjoying while we still can? So I'm going to talk about that also. Just to let me have some idea about how much you know about weather and climate change. Can anyone tell me some of the examples of extreme weather in this year, 2026? Yes, please. Yeah, or near. I mean, near today.
Well, floods in Indonesia, Typhoon Ragasa in Hong Kong. These are like extreme weather.
Thank you very much. Indeed, yeah, we have Typhoon Ragasa number 10 signal. Luckily, we are not severely. I mean, Hong Kong is a pretty well-built city, so we escaped severe damage. But when it landed over the Guangdong province, and as a matter of fact, it is really, really very damaging. Well, there are some latest development. Perhaps the news media haven't reported that extensively. It did. I remember it reported it. We just experienced the hottest Chinese New Year Eve ever in Hong Kong. I mean, ever means 140 years of record. And of course, we have other extreme weather events like very hot weather in Australia. Do you know that anyone play tennis? Anyone? Tennis? Yeah, good. So do you know what happens in the Australian Open? They have to stop the match every now and then for, I don't know, 10 minutes or 20 minutes so that the athletes can avoid the heat, avoid being heat exhaustion and so on. All right, so extreme weather events are happening every now and then, and it is worrying that it's getting more and more severe. So the real basic greenhouse effect. Why do we have global warming? Why do we have climate changes? It's all because of the greenhouse effect. And this graph here simply illustrates the situation in the past where we have an atmosphere with a relatively thin layer of greenhouse gas. Greenhouse gas means carbon dioxide, methane, CFC, and things like that. Now, because of human activity, we have a much thicker layer or highly concentrated amount of carbon dioxide and other greenhouse gases in the atmosphere. Now, when we talk about greenhouse gas or greenhouse effect, we have to know that it's not something evil. The effect itself is not something evil. Actually, to a very large extent, human survival and the survival of our ecosystem depends very much on the greenhouse effect. Because without the greenhouse effect, the Earth will actually become a snowball. It's estimated that without carbon dioxide, without water vapor, without methane, and so on, the temperature of the Earth will be something like minus 15 or 16 or 17 degrees Celsius. So it's going to be a snowball Earth. So really rely on greenhouse effect to survive. But as a Chinese saying go, if you have too much of something very good, then it perhaps is not really good. In the Chinese tradition, we like to eat abalone, we like to eat shark fins and things like that. If you have this kind of dishes every day, then probably you have high blood pressure and high cholesterol and so on and so on, right? So greenhouse effect is supposed to be good, but if it is too strong, then it causes all kinds of trouble. And this is the situation today. We have too much of the greenhouse effect. And greenhouse effects, I mean, as far as science is concerned, is something that's been known for a long, long time. As a matter of fact, the famous mathematicians Joseph Fourier postulated that the atmosphere, within the atmosphere, there must be something that retain the heat of the Earth after being absorbing the energy from the sun. Right? He calculated that using the distance between the sun and the Earth and the energy of the sun, that without this kind of mechanism, the Earth should be much, much colder than 0 degrees Celsius. So that was more than 200 years ago. And the first experiment to prove the greenhouse effect was actually performed by a lady, an American lady, Eunice Foote, in 1856. She performed a very simple and yet elegant experiment. she used a very big jar which contained and put in some gases. Some of them are carbon dioxide, some of them other gases, and try to find out the effect of temperature rise when they are put under the sun. And the results show that if the jar contains a lot of carbon dioxide, then the temperature rise is larger than the jar which contain other gases, for example, air, hydrogen, and things like that. And then this Irishman, John Tyndall, performed a much more elaborated experiment using spectroscopy and so on. You know, spectroscopy is shining infrared radiation through a certain instrument containing greenhouse gases. And that experiment demonstrated beyond any doubt that there are certain gases that are very effective in absorbing the heat of infrared radiation. And coincidentally, the radiation that is emitted from the Earth to outer space is within the infrared band. You know, infrared. I mean, all of you, even though you are not a science student, you should know about infrared, because after COVID, during COVID, when we go to a restaurant, when we go to even to the university, you have to be taken, you have to be scanned by a certain infrared sensor, which is to scan your temperature. So the energy that the Earth tried to get rid of and send it to outer space is actually in the infrared region. So the science is well established. Let's take a look at the effect of that much greenhouse gases, which is now residing in our atmosphere. This is a time chart of roughly over 1 million years. So this is 1,200,000 years, so 1.2 million years, right? So this is the current level of temperature, this dotted line. So you can see that around this period, called the Pleistocene, temperature rise and fall, rise and fall. And as if the Earth as a whole is a kind of large organic body that can control the environment such that everything can live and thrive within the Earth. And that is what we call the Milankovitch cycle. All right, this is mainly because of the movement of the Earth and the rotation of the Earth and things like that. And then from approximately 10,000 years ago, human beings started agriculture. Well, the carbon dioxide concentration, well, by the way, this is the carbon dioxide, the surface temperature, okay? So temperature started to rise as we grow crops. Why? Because agriculture is actually one of the major problems causing climate change and global warming. Because we need land to grow our crops. So we cut down a lot of trees. Just like someone talked about Indonesia, the heavy rainfall in Indonesia. For example, in Indonesia cut down a lot of forest in order to plant the palm trees, because the palm oil made use of in a lot of applications. So when we cut down the trees, the ability of the Earth to absorb the carbon dioxide is decreased. So as soon as we started agriculture, the global temperature started to rise very, very slowly, very, very slowly. And then probably we Chinese are among one of the culprits as far as climate change is concerned, because we started growing rice. I think, correct me if I'm wrong, Chinese is the first civilization that plant and grow rice. And the way we grow rice is that the paddy field is filled with water. And that environment is very similar to the swamp. And swamp are the places where methane gas is produced and released to the atmosphere. And methane gas is a very strong greenhouse gas, about 25 stronger than carbon dioxide in warming up the Earth. So that's why I say China is one of the culprits as far as growing rise is concerned. And then we started the Industrial Revolution about 150 years ago. We started using fossil fuel, and then the temperature rises rather quickly. And these are projections. I'm not going into the details because this is, suffice to say that SSP1, SSP2, and SSP5, and so forth and so on, are the kind of scenario in the future. We don't know which path we're going to take. Maybe we take this one, probably not. Maybe we take this one, and very unlikely we are going to take that one. If we take that one, which simply means that we are going to do nothing about climate change, no climate action, then our temperature will rise to a very high level. So these are projections in the future. And this graph is just to show that the change in temperature of the Earth as a whole, is very closely related to the carbon dioxide in the atmosphere. So the relationship is nearly linear, right? The higher the carbon dioxide, and then the higher the temperature. And then this one is actually zooming to this very close, very near, the last, how many years? 100 years or so. So you can see that from starting with the Industrial Revolution somewhere here, temperatures started to rise, but at a very, very slow rate, just 0.05 degrees C every 10 years. So this is very, very slow, despite the fact that it's also global warming. But starting in the 1960s, we see a much sharper rise in temperature with a rise 0.19 degrees per decade, which is actually some 4 times faster than before. And then if we zoom in to the last 10 or 15 years, this is a trend for the last 10 to 15 years, where the rate of rise in temperature is 0.31. So nearly 6 times as fast as this period. So we are not talking about just global warming. It's accelerating global warming. We're getting warmer and faster. So where do the greenhouse gases come from? Many of you should know that already. This is for the world, for the global average. Well, we generate a lot of greenhouse gases by generating energy, industry. AFOLU is agriculture, forestry, and land use, right? So we just learned that agriculture is actually producing quite a lot of greenhouse gases, transportation and buildings and so on. So this is for the Earth for the world as a whole. But for Hong Kong, the situation is quite different because Hong Kong, we don't have a lot of agriculture. We don't have a lot of industry, right? So for Hong Kong, it's basically energy production. For electricity, for transportation, and other fuels such as town gas. We burn natural gas, we cook cane and things like that. So it's nearly 90% or over 85% of the greenhouse gas production in Hong Kong is due to energy production. So for agriculture, it's really very minimal. So this is some picture that shows the places where, or the activities where greenhouse gases is generated. So you noted that there are some disagreement between this one and that one and that one, this one, because the situation varies from place to place. So suffices for you to know that where are the major sources of greenhouse gases production. We just learned that temperature is rising more and more rapidly. And one of the reasons is, of course, the carbon dioxide concentration in the atmosphere is rising very rapidly. So this is just a screen capture from the United Nations webpage saying that we just recorded a record rise in carbon dioxide level in 2024. So this is from United Nations Weather Agency, the WMO, the World Meteorological Organization. But if we look at this graph, each bar represents the annual increase. We're not talking about the actual concentration of carbon dioxide. It is the increase in the carbon dioxide from the original sort of level. So we can see that the increase is actually rising decades after decades, except with the exception of this one, probably because of some economic problem and things like that. If we zoom into this one, to this 10-year period, the rise or the additional increase is 3.4 ppm. ppm is a short form for part per million. So 1 part per million is 1 ppm. So what it means is that in 2011 to 2020, we added an additional 3.4 ppm to the atmosphere, right? But these are the additional increase in 2024 and 25, which is nearly 3.4. Oh, sorry. For that one is 2.4. So that represents from here to there, in a span of just 15 years or so, we see a 40% rise in the annual increase in carbon dioxide in the atmosphere. So this is exactly opposite to what we expect, what we aspire to, because we know that global warming is happening, climate is changing. We need to reduce the carbon dioxide in the atmosphere. But instead of reducing the carbon dioxide in the atmosphere, we are adding more and more carbon dioxide to the atmosphere. So that is a problem. This rise in carbon dioxide concentration in the atmosphere is despite the fact that Mother Earth is actually helping us to store away some of the carbon dioxide that we have emitted to the atmosphere. This graph is what we call the carbon cycle. You know, carbon, once it has existed in the Earth, will not disappear. It will change from one form to another, all right? It may be in the form of carbon dioxide in the atmosphere. It may be in the carbon in our body. It may be the carbon in the trees and also in the microbials in the soil and things like that. So it exists in different forms, okay? So this graph, the numbers may not be updated because this graph is probably 10 years or even older. Suffices to say that a human being emitted about 9 units. The unit is gigaton. Giga is 10 to the power 9. So there's 9 billion tons of carbon dioxide emitted every year. So this one is probably, right now it should be more than 9. So a lot of carbon dioxide is emitted by the human being because of various processes, energy production, transportation, and so on. And then the trees, actually through the process of photosynthesis, absorb 123 units. So as a first thought, you might think that there is no problem because we only emitted 9 units and the trees absorb 123 units. So the tree absorbed much more than we emitted. But the problem is not that simple because trees, like we human beings, also breathe. It breathes in carbon dioxide during the day and produce oxygen. But during the night, it also releases carbon dioxide just like ourselves. All right, so while through respiration, the plants also release quite a lot of carbon dioxide, 60 units. And then what's happening within the soil is that there are some microbial respiration and also decomposition. A lot of organic matter decompose within the soil. And that also releases quite a lot of carbon dioxide. So 120 units of release. The net result is that the Earth environment, what we call the terrestrial environment, absorbed 3 units, right? Out of the 9 units we emitted, the terrestrial environment absorbed 3 units. So Mother Earth is actually helping us to solve the climate change problem, but that's not good enough because we're emitting too much. And then over the ocean environment, the situation is pretty much the same, right? The ocean, through a lot of what we call air-sea gas exchange, just to let you know that all processes within the climate system are dynamic, right? So carbon dioxide is emitted, absorbed, emitted, absorbed, so it's a dynamic. But the problem is that the dynamic mechanism is not in balance. So similarly, in the ocean, we have a lot of small plants and animals called phytoplanktons. Very, very, very small individually. We can't even see them with our naked eye. But the collective mass is the largest within the ocean, much larger than the whales, the shark, and all the fishes added together. So these phytoplanktons are just like trees. They can undertake photosynthesis and absorb a lot of carbon dioxide. But just like the terrestrial environment, we have respiration of all the animals in the ocean, and then when they die, they decompose and they emit carbon dioxide. So the net result is that the ocean environment absorbs 2 units. So of the 9 units we emitted, the Earth helped us, our Mother Earth or Gaia, some of them called Mother Earth or Gaia, absorb 5 units, so about half. Right, so that's why we are seeing increase in carbon dioxide year after year, because Mother Earth cannot take the entirety of all the carbon dioxide of greenhouse gases we emitted. Forget about this one. This simply shows the rise in the carbon dioxide emission. But here is something worrying to me. The previous slide showed that Gaia, or Mother Earth, is helping us to store away some of the carbon, right? And this graph showed the ability of Gaia in storing away the carbon dioxide. Just 10, 20 years ago, it's on the rise. But since 2016, it's actually decreasing. It shows that there's something wrong with Mother Nature in storing the carbon dioxide. What is the reason? This graph actually shows the biomass. One of the major reasons is, of course, wildfire, right? If there's no wildfire, then the tree stores a lot of carbon. But then when we have wildfire, a lot of carbon dioxide is released. And the other is, of course, deforestation, cutting down all the trees and things like that, right? And we have actually one phenomenon which is called dying off of the rainforest. For example, I read with a lot of concern about some new studies suggesting that the Amazon forest, which is the largest rainforest in the whole world, which should be the largest carbon sink or carbon store of Mother Nature, instead of absorbing carbon dioxide, is actually emitting net carbon dioxide. So Amazon forest is not helping us to capture the carbon dioxide anymore. So that's why we have a decrease in the capacity of Mother Nature in storing the carbon dioxide. So this is something that really worries me. And now over to the oceans. The same thing happened. This is, I think, just a couple of years ago in 2023. You know, for this color, you have the strongest outgassing carbon dioxide coming out from the ocean. As I mentioned, it's always a dynamic process. Carbon dioxide gets absorbed into the ocean on one hand, but also being emitted or released from the ocean on the other hand. The net result is that the ocean is still absorbing carbon dioxide. But since we have strong outgassing, it means that we have weaker outtake of carbon dioxide. So you see the northern Atlantic and then the northern Atlantic and the middle Atlantic and then Pacific Ocean and so forth and so on has strong outgassing. So much so that we have, the ocean can absorb, is absorbing 1 billion tons less carbon dioxide than previous years. So forget about this very busy graph. Suffice it to say that we have energy coming from the sun. This is energy, actually the sole source of energy. 99.99% of the energy of the Earth is from the sun. It is reflected by the clouds, reflected by the surface of the Earth, and some of them are being absorbed by the ocean, by the land surface, absorbed by the atmosphere, and so on and so on. So you have a lot of numbers. And then after being absorbed by the ocean, by the land, then it emits radiation back to outer space. And this is what we call infrared radiation. Now, if you add up the number or do the arithmetic, find out the number of energy or the amount of energy coming into the Earth and the amount of energy going out, you find that scientists found that they are not balanced. There is a net absorption of energy. So what it means is that the incoming energy is larger than the outgoing energy. So that dynamic process is not in an equilibrium. It's not balanced. And we have 0.7 unit, which is watt per meter square of energy being absorbed by 1 meter square of land in the Earth. So this is actually a very small number. For those who study physics, you know 1 watt is actually a very small unit of power. For example, I don't know, for this lamp here, I mean the power of this lamp is probably 10 watts per fluorescent light, something like that. So a watt is actually a small number. But since the unit is watt per meter square, we have to multiply this small number by the total surface area of the Earth. And that will give us a very large number. And just to give you some idea, oh, where is that? Oh, I didn't put in that picture. Maybe in the next few slides. So it worries us that the amount of energy imbalance is on the rise. So this graph is produced maybe 10, 15 years ago, 0.7, 0.7 is somewhere here. So probably around the year 2010, 2012, and so on. But now we're over here. So we are already absorbing 1.25 units. So that is the reason why the Earth gets warmer and warmer, because the energy imbalance gets larger and larger. There is a concept which all of us should know, the 1.5 degrees threshold. So what does it mean? Actually, in 2015, about 10 years ago, we have a climate summit being held in Paris, what we call the Paris summit or COP something, conference or party something. There is an aspiration by all representatives of all countries in the world that we should try to contain the rise of temperature to within 2 degrees, measuring from the industrial era. And we should try our best, not just at 2 degrees, contain the temperature rise to 1.5 degrees. So this is the first threshold. Now we can estimate, using a very simple method, to estimate when that 1.5 degrees threshold will be breached. In 2015, we do that assessment using a simple method by extrapolating the trend. Okay, so these are the past data. These are the past data. So we use a linear regression and then extrapolate. And then when it cut to 1.5 degrees Celsius, the time is 2042. So still quite a long time away from us. And that is the estimate made about 10 years ago. But last year, when we do the same estimate using the actual temperature data, you can actually see that the rise in temperature is much, much steeper than this one. So the estimated time of reaching 1.5 degrees is March 2029, just 3 years away. Well, it doesn't mean the end of the world. But as pointed out by the United Nations chief, every 0.1 degrees rise in temperature matters. It matters particularly to those poor and vulnerable people. We'll talk about that later on. Yeah, that's right. We talk about the 0.7 watt per meter square. If we accumulate that energy for 50 years, it is the equivalent of 25 billion atomic bombs. 25 billion atomic bombs. The atomic bomb referred to the atomic bomb that the US dropped to Hiroshima during World War II. So that's a lot of energy, right? So I hope, if anything, this number should scare you. A lot of energy is being stored in the earth. So this is global warming and climate change in a nutshell. We have more and more greenhouse gases. The earth gets warmer and warmer. And then the rise in temperature actually distorts the weather pattern. You know, we have different weather patterns. For example, right now we're still in wintertime. We have winter monsoon, and the winter monsoon is actually caused by the temperature difference between the north and the temperature difference between the south, the north and the south. So temperature is the driver of a lot of weather events. Okay, so when the temperature changes, then these weather events will change. And of course, the consequences are very complex and very complicated, but I'm going to focus on just the rainfall aspect. So this is a time series from 2004 to 2020 about the occurrence of wet extreme, which means flooding, heavy rainfall, and then dry extremes, which means drought and so on and so on. So you can notice, you can see that the area affected per month, km square per month, is actually much larger. Is actually much larger, right? As time evolves. So weather becomes more and more extreme, and that is the things that is worrying us. To give you some idea, we started with temperature rising, global warming, and then one consequence of global warming is that we have a lot more evaporation from the ocean, right? We have more moisture in the atmosphere. And more importantly, the atmosphere, because it is now warmer, can hold more water vapor than before. Right? So we have more water vapor in general in the atmosphere. So that when the weather situation is such that rain should occur, for example, if we have a trough of low pressure, right, near Hong Kong, then it is a situation where we can get a lot of heavy rain. If that weather pattern occur, then it would dump more rainfall to our area because the atmosphere contains more moisture than before, right? So that is one thing. So we have more heavy rain, increased flooding, and this is one kind of extreme weather. And then the other aspect of more moisture in the atmosphere is that moisture is actually a source of energy for a lot of weather system. And the weather system we are most interested in is, of course, typhoons, tropical cyclones. The fact that tropical cyclones swirl so quickly, the winds are so strong, the rains are so heavy, is because it derived the energy from moisture. when the water vapor condenses into water droplet, a lot of energy is released, what we call latent heat of energy, right? So because we have more moisture in the atmosphere, it releases more latent heat, and then the storm becomes more violent. I don't have a slide with me here, but someone calculated, make a study of the number 10 signals, typhoon signals in Hong Kong. For those who are not from Hong Kong, number 10 signals means the highest number or the situation which is more dangerous during the approach of a typhoon. So before, I mean, in the 1900, in the in the 20th century, we have something like 10, 13 number 10 signals. And of all of those 10 number 10 signals, those which are caused by super typhoons, if I remember correctly, super typhoons is causing those number 10 signals for something like 15% of the time. But in the 21st century, so we just 25 years passed in the 21st century, we have something like 40% of the number 10 signals are due to super typhoons. So this statistics show us that we have much higher chances of encountering super typhoons now than before, right? And that is because of that reason, because we have more moisture, more latent heat, and so on. But that one is interesting. We just mentioned that because of global warming and so forth and so on, we have increased flooding. But on the other hand, global warming also caused increased drought. So this seems to be contradictory, right? The reason is, of course, now with a higher temperature, the atmosphere needs more moisture in order to become saturated, okay? So you need more evaporation, more pumping more water vapor into the atmosphere before it becomes saturated, and then clouds can form. Now, because the atmosphere can contain much more water vapor than before, you need to pump more water vapor into the atmosphere before you have rain. And therefore, in a dry situation, you become drier because it takes much longer time for the atmosphere to become saturated, for rain to occur. So that superficially seems to be contradictory to one another, but as a matter of fact, it isn't. So that's why we see increase in drought and also increase in flooding and heavy rainfall. So these are not contradictory. We have a branch of science called climate attribution or climate change attribution. A group of scientists, interested scientists, use computer models to study a lot of severe events. It could be drought, could be wildfire, could be hurricanes and things like that. And they try to find out whether or not climate change is playing a role in the sense that it makes the extreme weather more severe or more frequent or more likely, right? Now, I have to make a very important point, which is climate change is not the culprit of extreme weather. Climate change doesn't cause extreme weather because extreme weather has been occurring for millenniums, for thousands and tens of thousands of years before, right? But the problem is that climate change exacerbates those extreme weathers, make those extreme weather much worse. So that's the main point. So you have a study of some 750 extreme events, right? Those events which are represented by red colors, for example, like those in Northern America, Europe, and Eastern and Southeast Asia, are those extreme events which is made more severe or likely as a result of climate change. So the red represent about 3/4 of all the 750 events studied. There are, of course, some other events that science or climate change attribution cannot find out any influence because of climate change, and even some extreme weather event becomes less severe. So the most obvious one is that the cold surge in many parts of the world becomes much milder. Right? We still have record-breaking cold surge, but the frequency of that occurring is much less. So there are some cases where extreme weather events are actually less severe. Let's turn our attention to China. You know, you have a lot of extreme weather events being studied in Eastern and Southeast Asia, and some of them, of course, occurred in China. So out of 114 attribution study, 88 studies. So this roughly is around 70% or 75% of those cases happening in China are made worse as a result of climate change. And one example is the drought a couple of years ago. Anyone from China living near Changjiang? Anyone? I was in China in Yangtze River, Changjiang in 2023, and the water level was still very low, even 1 year after that drought. And during that year, some of the, Changjiang River actually dry up in some places. So that is a very severe drought. And the most importantly, the conclusion of that attribution study said that human forcing has increased the likelihood of drought, such as in 2022 by 65 times. And that to me is unbelievable, right? Drought have occurred in China throughout our civilization, throughout our history. But this kind of drought is made by climate change to happen much more frequently. So, weather and climate. This guy, 2014, that guy is really, after that many years, 12 years, his look doesn't change much, right? Despite the fact that he's already quite old. So that was what they call the political rally. He ran for president, right? So there are political rallies and so on. And he was in New York. And during his political rally, he said, it's supposed to be 70 degrees Fahrenheit. Well, you know, anyone from US? Anyone from United States? No? United States is still a very strange country to me because everyone, all countries in the world, with the exception of the US, use metric system. And they are still using Fahrenheit, inch, and things like that, right? So I think 70 degrees is something like 20 degrees Celsius. So he said that it is supposed to be 20 degrees Celsius, but it's freezing here. As a matter of fact, when he spoke, there was a snowstorm happening in New York, and he said that, where is global warming? So what's wrong with that statement? Trump said that it should be, the weather should be very mild, 20 degrees Celsius. But instead, it was freezing out there, snowing heavily out there. And based on that observation, he said that where is global warming, which means, he's trying to say that global warming is not true. So what do you think about his statement? Anything wrong? Well, when we talk about global warming, We're not talking about New York. New York is not the world, right? We're talking global warming. So when we talk about global warming or climate change, we talk about the world as a whole. We talk about the trend of temperature rise for the world as a whole. Even for a certain city like New York, when we talk about climate change, we talk about the long-term trend. There is always some kinds of extreme cold and extreme hot events happening here and there, right? But what we are concerned is the long-term trend. So this is the temperature, and normally exactly in January 2014. So he was making that statement in 2014 January. Meteorologists try to use the blue color to represent the cold weather, and then the red color for very hot weather. So actually, Trump was not lying. Well, in the northeastern part of the United States is actually colder than the normal. So that's why you have the blue color. Blue color is represent cold anomaly, and red color represent hot anomaly. But while this part of the earth world is cold, you have Alaska, which is exceptionally hot. Greenland is exceptionally hot, and Europe very hot, and also China exceptionally warm. As a matter of fact, I was in Australia at exactly the same time, and every day the temperature was in excess of 40 degrees Celsius. I was in Queensland, somewhere here. I was doing a documentary for Radio Television Hong Kong, which is the government channel, TV channel. So even when Donald Trump complained about the cold weather in New York, the Earth as a whole is actually still warming. So the key point is that we have to consider two aspects. One is a spatial aspect, one is a temporal aspect. When we talk about global warming, we really mean global. We do not mean just one place, right? When we talk about the time, then it should be we should be concerned about the long-term trend. So, as far as carbon dioxide is concerned, it's rising. As far as temperature is concerned, it's rising. It's also rising faster and faster, and so on. So there is a famous astronomer. He's also a very good science communicator. He was kind of KOL. He has a lot of YouTube channels. Dr. Neil deGrasse Tyson. He also talked about weather and climate. So he used a very good analogy, which I think is a very good analogy. So he's walking a dog. So this is the path taken by Dr. Tyson. But the dog is meandering, right? The dog tried to walk this way and that way. And to him, to Tyson, the dog's path represents the weather. The weather is changing. And then he said, keep your eye on the man, not the dog, when we talk about climate change. This represents the climate. This represents the weather. So climate, on a very simple term, is average of the weather. Right, more about Trump. This is his second term in office, and he has done much more harm to climate change and climate actions, and also climate study, climate science in US and all over the world. This is a cartoon, which is very, which strike a chord with me. He was literally throwing the climate change report into the rubbish bin. You know, for those of people like me who are interested in climate change, I often look up to some of the government website of the US, for example, NOAA. NOAA stands for National Oceanic and Atmospheric Administration, much like the Hong Kong Observatory here in Hong Kong. Of course, NOAA is much bigger. And then the other organization is NASA. You all know NASA, right? the National Air and Space Administration. So these two organizations of US publish a very, very strongly scientific evidence-based report year after year. And now if you go to the website, if you search for example, the report in 2024, it's not available. If you search for the report in whatever year, and then the website tells you that the report is not available. So literally, Donald Trump is dumping all those important reports into the dustbin. And then that's happened about 5 months ago, September 2025. You have a United Nations General Assembly held in New York. And he spent a very long time talking about climate change. His speech, I don't remember, maybe about an hour long. He spent a lot of time talking about climate change. And one of the key sentences or key message he made was that climate change is the greatest con job in the world. Con job. Deceit, right? It's not true. It's something made up by some other country, maybe China, right? He once said in Twitter that global warming is manufactured by China in order to help the Chinese industry and to make the US industry less competitive. Things like that. So that's why I describe this man as morally corrupt. Why do he say that? He's not a scientist. What right does he have to come to that kind of conclusion if he's not a scientist, right? And the sole purpose of Donald Trump making all these statements is to protect the rich, the polluters, who get the money because of polluting the earth, and then harming the most vulnerable people. So that's why I called him one of the most morally corrupt person in the whole world. I'm not going to talk about all these climate denials, but maybe let's, for example, talk about this statement he made. He always used Twitters, right, as kind of an official channel to voice his own opinion. You know, they don't call it global warming so much now. They call it climate change because it wasn't working. Global warming wasn't working when it's cooling. So he still say that there is some cool weather every now and then, so there is no global warming. So now they call it climate change. That takes care of everything. Well, as a matter of fact, there is a very interesting story about the competition between the two parties of the US. The main two political parties are the Republicans, of which Donald Trump is a member, and also the Democrats, like Bill Clinton, like Obama, and so on and so on, right? And then there was an advisor called Frank Luntz to the Republican Party. And Frank Luntz asked the Republican politicians to refrain from using the word global warming because, to his opinion, global warming is a bit alarming. And Frank Luntz suggested they should use climate change because climate change is kind of neutral, because change maybe could change for good, maybe change for bad, right? So that was actually the party line of a Republican advisor about 10, 20 years ago. And why did Frank Luntz suggested that party line of not using global warming, but using climate change? Because historically, the Democrats are more concerned about environmental issues, of which climate change is one of those environmental issues. So Frank Luntz was afraid that the Republican Party would lose on the ground of environmental issues. Therefore, they try every methods to try to play down, all right, the importance of climate change and so on. All right, so that is the harm being done by Donald Trump. This is just an estimate because Joe Biden and Donald Trump initially run for president, but later on because of health problems, so Biden withdrew from that. There is an estimation by, I think this is a Climate Central or Climate Brief, that if Trump becomes president, the carbon dioxide emission will still go down. But if Biden becomes president, the carbon dioxide emission in the US will go down more quickly, right? This is obviously because of the political inclination of the two presidents in regard to tackling climate change issues. But either for Biden or Trump, this is a lot. I mean, the gap is still very wide. This is the target as suggested by scientists and so on. But now on the right-hand side, we have one of the latest development that happened just a couple of weeks ago. And then what is said is that the Trump administration revoked scientific finding that's underpin the US fight against climate change. And that finding was called the endangerment finding. What does that mean? Endangerment finding, and endangerment is endangering something, make something dangerous. And that endangerment finding was published or promulgated in 2009 when Obama was the president. And that was a time that the US EPA declared that greenhouse gases are air pollutants. Never before in any parts of the world that any country would treat carbon dioxide as a pollutant. But in 2009, because making use of scientific-based argument, if we have more carbon dioxide in the atmosphere, we have more extreme weather and so forth and so on, it will eventually harm the people, not just in the US, but all over the world. So that is the basic principle or the argument of the endangerment finding. But then Trump is trying to revoke that scientific finding. I don't know how he did that. If you revoke a scientific finding, you have to have scientific evidence supporting that carbon dioxide is not harmful to human. I don't know what is his scientific basis for revoking that finding. So probably, there will be a lot of lawsuits going to the Supreme Court or whatever. But the significance of this revoking of endangerment finding is that the US EPA, the Environmental Protection Agency, will become totally powerless in controlling emission of carbon dioxide and other greenhouse gases. Right? That's why you have that gap between Trump and Biden, because Biden will follow the predecessor, namely Obama and so on, with that endangerment finding principle. So how much time do we have? Time flies. I don't have a lot of time left. Well, let me talk about impacts of climate change very quickly. We just talk about rising temperature and things like that. In the context of SDGs, Sustainable Development Goals, we have 17 of those. And basically, climate change directly or indirectly affect each and every of those SDGs. I'm going to choose one or two of the most important things. For example, the first SDG is we aspire to the wish that there will be no poverty in the whole earth, right? But obviously this is easier said than done. This is published by Lancet, a very famous journal, scientific journal on health in 2020, last year. So they're making use of the data in this 34-year period. And you can see that during this 34-year period, the earnings lost by the labor sector is getting larger and larger because of climate change. In particular, because of heat exposure, temperature rises, where more heat wave and so on. For those labor sector, it's not like Professor Chen or Dr. Kwan or so on, that they have a monthly salary, all right? And their salary, most of them, the salary on the basis of the output. So if you are working in a factory, you produce a lot of products, and you get more salary and so on, right? So if you have more heat wave, then you have to stop working longer. If you are in the agricultural business, construction and manufacturing services and so on. Just like one example I talk about is that during the tennis Grand Slam in Australia, even the athletes has to take a break every now and then to avoid heat exhaustion. Just in case you don't know, you are not familiar with, a couple of years ago, the Hong Kong government has a guideline asking those construction workers, right, and other workers exposed in the exposed environment to take some rest and drink more water when the very hot weather warning was issued by the Hong Kong Observatory. Right, that is, of course, a loss of what they call the work hour, and therefore the earnings or decrease of earning is increasing with time. And then this chart shows HDI. HDI is what? Health Development Index, something like that, which is very closely related to the economic development status of a certain country. So you have low HDI group, which are basically poor countries. And then on the other hand, you have very high HDI groups, which are developed and wealthy countries, and so on. So for example, for the agricultural sector, then for the poor countries, they suffer a lot of losses. And then for the very rich countries, they still suffer, but not to that extent. So this is, one of the impacts that I concluded that the poor gets poorer. And then the other SDG is that we would like to get rid of all hunger, zero hunger, right? But unfortunately, as a matter of fact, as we speak right now, we have 700 million of people who are facing hunger right now, as we speak. So this is a map of what they call the food insecurity map. The darker the color shows the percentage is much higher where people suffer from hunger and so on. And that brings out another issue of climate change, which is climate justice. You see, of all over the world, those countries which are facing the highest extent of food insecurity are the poorest countries in the world, like in Africa, like in South America, like in Middle East and so on. So climate change is making food production much more difficult because of a number of factors: warming trend, extreme temperature, drying trend, extreme precipitation, carbon dioxide fertilization. I'll talk about that later on. And then ocean acidification. So these are factors which contribute to loss of productivity of agriculture. So population of the world is still growing, but on the other hand, we face more challenge in terms of production of agricultural produce. So feeding the older people in the world becomes a much, much larger challenge than before. So it's very challenging to reach that SDG. But what is interesting in this graph here is that this shaded area, the shaded area is by applying good technology, we can actually reduce the risk of food insecurity, okay? So right now, the risk of food insecurity is not very high. It's actually low. It's actually low. Why? Because the world as a whole actually produces enough food for each and every one of us, 88 billion people on Earth. But the problem is that there are parts of the world which consume much more than a fair share. And because of, I mean, because of the practice by some of the farmers, sometimes they throw away the produce instead of pushing the produce to the market at a lower price, right? They rather throw away the agricultural produce than selling their produce at a lower price. So because of that practice, then not everyone in the world has enough food to eat. But the importance is that in the near future, the risk will rise from low to medium. But that's still okay because we can apply all kinds of technology to reduce the risk to the current level. So this is the amount of risk reduction. But notably, if the temperature get too high, the global warming get too intense, the risk becomes very high, and we have actually no way of reducing that risk. Because once we reach a threshold, then probably no technology can help us to reduce the risk. Again, this is the population, published by Lancet, population reporting moderate severe food insecurity due to heat wave and drought. So over how many years? About 10 years, right? About 10 years. Starting from 1% to now about 3.15% as a result of heat waves. Because we have more heat wave, because the heat wave is stronger, so the food production becomes a problem. And to tell you a story, before I retire, I actually thought about becoming a farmer. I like to grow things, right? But after considering all the risks that I'm going to face, extreme weather, typhoons, flood, and drought, and so forth, so on and so on, I just give it up. I just give it up. So exactly, because in just 10 years, just about 10 years, we have more heat wave, and then the percentage of people suffering from food insecurity rises from 1 to 3%. In terms of percentage, is 300 times increase, right? And we're concerned about drought, then the situation is pretty much the same. So from 0.5 percentage point to now 2.23. So when we add this two threats together, then the situation is even more severe. This one is very interesting to me, I think. Mycotoxins. It's just some kind of mold, right? With wetter weather, with warmer weather, you get more fungi growing on the crops, and then they will produce mycotoxins. And some of those mycotoxins are carcinogenic. Right? So if it's turned so badly, then obviously you will not eat it. But there are some produce which contain small amount of mycotoxins, small amount of fungi, so that you don't notice. and then you eat it, and then you run into the problem of maybe developing cancer later on. So the fungal growth will enhance the growth of the present mycotoxins from the produce. And then when we have drought, not enough water, it's not entirely drought, it's not such that nothing can grow. We still can grow a little bit of produce, but because of lack of water, then the crops will accumulate the nitrate instead of converting it into protein. Now that the consequence is very important, because for many people in the developing world, the source of protein is from agricultural produce, right? Eating maybe soybeans and other corns and so forth and so on, that contains quite a lot of protein. For us, for the well-developed countries of rich people, we can of course have beef and chicken and fish and so on, so that we can enough protein. But the problem is that when we encounter drought, then the crops take up the nitrate from the soil, but cannot convert it into protein. So what it means is that the food becomes less nutritious, because the protein content is not good enough. But then the other thing is that nitrate, once it is eaten, get into our body, will be turned into another chemical, which is carcinogenic. So the food that we produce under dry conditions is, one, not nutritious, and two, there is a threat of, getting you to have some kind of cancer and so on. And then earlier on, I talked about carbon dioxide fertilization. What does it mean? In very simplistic view, or simplistic term, plants or our agricultural produce rely on carbon dioxide in the atmosphere, because we have photosynthesis, right? Photosynthesis is that the plants absorb carbon dioxide and water and then make use of the energy from the sunlight and turn it into carbohydrate. And that is the process of photosynthesis, right? So the idea is that now, because we have much more carbon dioxide in the atmosphere, then there is more food for the plants. Is that right? Because plants need carbon dioxide. So now we have more carbon dioxide. Isn't it more favorable for the plant to grow? So that is what they call the carbon dioxide fertilization. So just like more carbon dioxide in the atmosphere, just like adding more fertilizer into the soil and so on. But there's a problem. There was a study which is performed experiment, which is performed by growing plants in carbon dioxide-rich environment. So just like in a greenhouse, so you can eject carbon dioxide into the greenhouse, and they find that under that condition, wheat will contain less zinc and less iron and less protein with more carbon dioxide in the controlled environment. So, well, in one single conclusion, the food becomes less nutritious. All those zinc and iron are what we call micronutrient. We need them. We don't need a lot of them, but we need them in order to have healthy body. But because it's significantly reduced, then it is going to be a problem. And then this is about marine produce. I like seafood. I think every one of us likes seafood, unless you are allergic to seafood. As a matter of fact, for Chinese people, in a span of some like 50 years or 60 years, the consumption of seafood by Chinese is 10 times more than 50 years ago. So we are eating a lot of seafood, fish, and so on and so on. But then because of climate change and other reasons, seafood production is under threat. Nitrogen over phosphorus ratio has nothing to do with climate change. So I'm not going to talk about that. It's actually an indication of pollution. But then we have hypoxia and acidification. Hypoxia means that we don't have enough oxygen in the ocean. So the problem arises. All fish and all kind of animals require oxygens. So and when we have hypoxia, then some of the fish will die. So there is a term called the desert in the ocean. All right, you in the desert on the land nothing grows, and then in the ocean we also have desert where no animals can thrive. And acidification is because carbon dioxide, when it's dissolved in the ocean, will becomes acidic. And that is not favorable for marine animals like shellfish and so on and so on. And then some of those most basic of the food pyramid in the ocean is miniaturized. So getting smaller and smaller and smaller. So what it means is that the food base is getting narrower. And then we have some kind of this kind of animals. I don't know how to describe it. Is a kind of plants, right? Just like when we see the algae bloom. Some of them could be producing toxins, and then those toxins might get into shellfishes because shellfishes like oyster is actually filtering, the ocean water, such that the toxins become much more concentrated in those shellfish and so on. So all these are indications of the fact that because of climate change, the ocean environment is changing so that it's no longer favorable for the marine animals to thrive. And then of course we have a marine heat wave and things like that. And how much time do I have? 5 minutes. Okay, so probably I'll skip that one and come to the last, I think, which is most important. This one is cute. This is actually a photography competition, A Tale of Two Foxes. So this is very cute, right? When I show this picture to my granddaughter, and she asked me, can I keep one at home? Obviously, you can't. So this one, the habitat is in the Arctic region, very cold region, all right? So everyone love it. But this is the fate of that Arctic fox. It's being eaten by a brown fox. So what it means is, this picture get the very high honor award because using that picture, it shows that biodiversity is in danger because you have enhanced antagonism of different species. Because in the old days, the brown fox wouldn't venture into the Arctic region. Now, certain time of the year, the Arctic region becomes very warm. Have you heard about the fact that temperature in Siberia exceeded 30 degrees in summer? Right, 30 degrees in summer, Siberia, which is supposed to be very cold. So because of global warming and because of one important mechanism, which is called Arctic amplification, the Arctic is warming up much faster than the rest of the world. So there are times when the Arctic weather becomes very mild, and those brown foxes ventured into that area and found his new prey. And that is perhaps one of the reasons where biodiversity is in danger. Okay, assuming it's Hong Kong, and forget about that. So are we doomed? And that's a very important question we should ask ourselves. If we took the right step, right, if there is no Donald Trump in the world, then obviously we have lots of solutions, because this graph shows that we can produce, we can provide energy security and climate solution using solar energy or renewable energy. So this map shows that basically the entire world has superabundant, abundant, and replete. Replete is more than enough, all right? With the exception of a very small area where they don't have enough renewable energy. So renewable energy is a solution. We do have enough renewable energy to solve the climate crisis. The problem is whether we have the will to follow that path. But then the good news is that China is taking a very aggressive role in making use of renewables. So you can see you have a solar panel production, wind turbine production. You have, this is for the whole world, about 600 gigawatts of energy produced or equipment which can produce 600 gigawatts. You probably have no idea what a gigawatt is. Anyone? No. Just give you an example. Across the border, we have a nuclear power plant. There are lots of nuclear reactors. Each nuclear reactor roughly produces 1 gigawatt of power. So we are producing quite a lot of clean energy, and most of them are actually produced by China. And similarly for wind turbine, right? So China is taking the lead, although China do not announce publicly that we are going to take the lead, but actually the action shows that China is taking the lead. We should be optimistic because there is an organization called IEA, International Energy Agency. They projected that if we use enough solar energy, we've used enough wind energy and also nuclear. By the way, nuclear is not renewable, although nuclear is very low in terms of carbon dioxide emission. It is not renewable. So IEA projected that if by 2030 we use that amount of solar energy and wind energy and nuclear energy and so forth and so on, we should be able to reach zero carbon by 2050 if we follow that path, right? And then that path is illustrated in this here, IEA net zero. But as a matter of fact, this dark color represents the production capability of China, projected, all right, production capacity of China, and that for the whole world, actually exceed the requirement of IEA. So if we follow the path, then we should be able to reach net zero by 2050, right? And then lastly, I would like to point out that China's effort, particularly with President Xi becoming president, I don't know, in 2012, I think. As soon as President Xi becomes president, he proposes one central, what we call the policy guidance and things like that. It's called ecological civilization, all right? In the old days, we have, in the days of Jiang Gongzhangmen, Jiang Zemin, they have 3 important principles. And then Hu Jintao, you have 4 important foundations of principles. Now, the era of Xi, you have 5 pillars of policy principles. And one of those policy principles is ecological civilization. So China's policy is following that path, and we're actually doing the world greater good because we are seeing exponential decrease in the price of solar panels and wind turbines, and we are seeing exponential rise in the efficiency of solar panels and wind turbines. And that comes at a cost. It didn't fall from the sky. It comes at a cost. And that cost is a cost for R&D. You have to invest a lot of money to do R&D. And that is what exactly China is doing. China is pouring state money of billions, hundreds of billions of dollars into research of renewable energy technology. So actually, we are effectively functioning as a green subsidy for the whole planet. And we also solve the problem of the tragedy of commons for the whole world. Why do I say that? You have heard about tragedy of commons, right? The idea is that everybody knows that we should not be doing that. But because of short-term economic benefits, we still commit ourselves to doing that. So what is that analogy in this case? The case is that we know that we should not be not developing clean energy. All right? Or put in other words, we all know that we should be developing clean energy, but nobody is doing that. Look at the chart. More than 90% is done by China, right? Why? Because you have to invest upfront a lot of money in research and development, right? So therefore, a lot of countries refrain from doing that. And that is actually a tragedy of the commons. And China actually helped us solve the tragedy of commons. And as a result of that, a lot of solar panels, wind turbines are sold to other countries, in particular the developing countries, at a much lower cost than before, than 10 years before, and so on. And that helped the whole world to decarbonize. So you have a lot of, revolution. The first wave is done by the Industrial Revolution led by United Kingdom, and then the steam engine and railway led by United Kingdom, and then by US. And then I think we have the sixth wave of revolution. And that wave of energy revolution is renewable energy, electrification, and resource efficiency. And this time it is led by China. So with that, I think while we should not be overly optimistic, we should, on the other hand, should not be pessimistic. There is a real reason that we can achieve carbon neutrality. Thank you.
Thank you, Professor Leung, for your
Q&A?
presentation. Yeah, so open the floor for Q&A section for a short one due to the time. And for online participant, you can type your question in the chat room. We will read out for you. Any questions?
Dr. Guan, maybe you can share my PowerPoint because I only finished maybe 1/3 of my PowerPoint. So maybe you can share that with the participants so that they can find, they can see whether the information there is useful.
So Professor Leung, so if you've just mentioned about 1.5 Celsius degree, so if we can keep 1.5 Celsius degree and then not reaching out,
We can't.
then why we should be optimistic about this?
No, as I said, 1.5 degree is not the end of the world. We can overshoot. There is one scenario that we can overshoot 1.5 and even 2 degrees, and then we can come down with technology, which is, of course, carbon dioxide capture and things like that. So, the first thing is, of course, reduce carbon dioxide emission and eventually get back to zero carbon. So don't worry too much about 1.5 or even 2 degrees. We can overshoot for a short period of time and then we come down again.
And we have students here, and who are the future leaders of our society, and what you wish to them to do in terms of the compacting climate change?
I think we need idea. We need more people doing more research. Just like what I mentioned in the last few slides, uh, um, science and technology is the ultimate solution to climate change, to problem of this magnitude. Of course, we always say that we can change our behavior, but this is always easier said than done. We know that eating beef is bad to environment and bad to the climate, but beef is really tasty. Are you are you ready to sacrifice beef for other dishes? Not many people is willing to do that, right? So changing our behavior is of course very good because, as I said in many other occasions, that the effect of changing our personal behavior is immediate. It's immediate because, as I said, we need science and technology to solve the problem once and for all, but it takes times. Just like solar panel, wind turbines, it takes 10 years and more to come to the current state of level. But it would change our behavior. The effect is materialized overnight. For example, if you stop driving, if you fly less, then the carbon emission will be immediately reduced, right? So that's why we still advocate change in behavior, personal behavior. Yes, please.
I want to ask, how is it significant in the behavior emission compared to the structural and industrial emission?
Sorry, can you repeat your question?
Is it significant are the differences between the behavioral emission compared to the structural and industrial emission? Which one is more
Yeah,
common?
I understand your question. I personally, my interest is on the basic science of climate change. So this is not the area which I'm really interested. But the important point is that in solving climate change problem, there is no silver bullet. There is no silver bullet. We need to employ all workable solutions at the same time. So to answer your question, let me think. It's very difficult to put a number because the number changes all the time, right? If you change your diet, you can look up the internet or maybe DeepSeek or whatever, and then you compare the carbon emission of eating a dish of beef and a dish of tofu, which both dishes are rich in protein. And you can already see a drastic reduction in the carbon dioxide emission. I don't know the exact number. I don't remember the exact number, but the numbers are significant. It's significant. It's very difficult to compare the effectiveness of personal behavior changes with the use of technology, because technology is always evolving. It's always evolving. So all I need to point out, all I want to point out is that we should make use of every non-workable solutions as much as possible. And a change in human behavior is one of those, which is very effective. I can't quantify how effective, but it is effective. take my word for it. Yes, please.
The honored participant, it is from Aston from Leung. So I would like to ask, as the age of AI technology is ongoing, do we feel it is going to be a major pusher for solving or improving the climate or boosting the green technology industry? And how would that be done?
Oh, I can't answer that question because I am an idiot in terms of AI. But obviously, I see a lot of applications that give rise to very encouraging results. For example, in the realm of weather forecasting, right? The Hong Kong Observatory has been using AI for the last couple of years. And they find very encouraging results in terms of forecasting the movement of typhoons, right? And that is not achievable by the conventional or traditional, what we call numerical weather production, which is using computer models, inputting the data, and then solving the mathematical equations and come up with the forecast and so on. So AI is obviously very powerful, but it all depends on how we apply AI to solving the problem. Because on the one hand, the promises made by AI is very encouraging. On the other hand, it causes a lot other problem. For example, it uses a lot of energy, and you have to solve. Yeah, I mean, you have to take the application of AI in a holistic manner, rather than I mean, tackling one problem at one time and disregarding other problems. So you have to have a very broad, general plan for using the AI. Sorry, I cannot answer your question because I'm not an expert in that area.
Okay, one more question.
Continues same question that continues the question about the AI, but the more concerns are about how can we tackle the problems causing the global warming due to the AI power race, because every company is now creating a lot of data centers that to train their AIs, and which causes a lot of problems. I think that during this 5 years from the 2020, it crucially increased the impact on the environment, everything that's happening with the AI companies.
Yeah, that's a very good question, and unfortunately, I can't answer that question. I think we need to really, the world as a whole, really need to think about that problem very seriously, because well, it's just my impression that a lot of people are using AI for funds, just like what we have during the Chinese New Year. We have animations impersonating myself or my friend, creating images or movies and video for greeting purposes, and that is to make use of the AI platforms and so on. So what I want to say is that we know that AI is very powerful, it's very helpful, but we should focus the application of AI in solving real life problem, rather than treat AI as a kind of new entertainment or things like that. And of course, for corporations, for AI corporations, they really have to think about the energy problem, how to effectively reduce the electricity consumption, and try as much as possible using renewable energy. I don't know whether it's true or not. Maybe, for example, Google has announced previously that they will be using entirely 100% renewable energy for running their AIs. I'm not sure. I'm not sure because I don't know how they come to that conclusion. But there must be some realistic approach that we can do. So again, I can't answer your question. Sorry for that.
Okay, so because of the time, okay. So once again, thanks Professor Leung for sharing your insight. To show our appreciation, may I invite Professor Chen and Professor Hui to present a certificate to Professor Leung on behalf of the UNICAP team. Wait. Yeah. Yeah. Okay, so please be seated. And Professor Chen, you would like to share the updates on the UNICAP activity.
Thank you, Dr. Guan. So for the UNICAP, we have some more upcoming exciting activities. So as I just mentioned, this is the very first capacity training activity today of this program. And then, oops, okay. I would like to go back to slide 9. Yeah, thank you so much. So what about the next one? Next one, we will go to the University of Hong Kong to have another training. That's in the morning will be the presentation of the master students, where some of the mentors will give the presentations for the project, while the mentees, who are the climate ambassadors of this program, will enjoy the presentation. And then in the afternoon, we are going to have another training session, which is delivered by Dr. Sonny Ma and Dr. Peter Lau, who are going to talk about student partnership and how to carry out climate actions through the lens of students and with the in the higher education. And then in the coming months, we were going to have the field trip in Maipo, and then with the use of we will learn about the how Maipo wetland management will deal with handle with the use of the AI and tech to manage the wetland. And then afterwards, we have some more co-creation sections. So this field trip is confirmed. We're going to go to the desert in July. And only 12 climate ambassadors will be selected. And then the details will be announced very soon. And I believe that the students properly, the 12 selected students properly, no need to pay anything to go to enjoy the 7 or 8 day trip. Okay, so they're going to trek over the desert and do some service learning there, and then meet with the youth from other parts of different parts of China as well, and also in different places. So this is how I experienced in the previous years and trek in the desert. So I'm going to announce it very soon, perhaps in the coming weeks. All right. So in order to complete these programs, in order to have the completion of the certificate of completion, so the students need to finish 70% of the attendance of the activities. That's 20 hours of the activities. And then the certificate will help you to add your profile for for your profile. And then because the certificate will be shown to some employers as well, so it will be enriching your profile. So may I now pass the time to Dr. Kwan?
So this is the group photo time. So may I invite students to stand up and get closer, move closer. So maybe some of you maybe are able to gather at the stairs, and then we're able to take group photo. Okay, we may stand like here. So I passed it to Jason to facilitate the group photo.
So everyone please stand closer to the middle. Hãy翻落少少，係啦，中間有個窿。UNICAP 使唔使我哋調啊？同大學
UNICAP 可以同兩個咧，你兩個，快啲快啲。
等佢哋入翻，可能企入少少，嗰邊都要6、3個同學企入少少，呢邊仲要企過嚟啲，係 OK， 可以嘅 OK，3、2、1。
係 OK。等一陣，仲要係咪要一個冇 banner 嘅都 ？OK， 好，分輯，one more picture，one more group photo，thank you。
3、2、1。OK，very good。
Okay, so one more thing to go. So may I invite you to fill out a questionnaire for us to collect your feedback and comments to our seminar as well as our program. So please scan the QR code before you go. 填咗先好走啊！ So for online participant, please also fill out the questionnaire for us.
For the UNICAP student who still haven't taken the attendance, please come down to take the attendance if you still haven't done it so just now.